Okay, let's talk about subclass. As we mentioned before, among these entities, besides the regular relationships, we can create some other special relationships connecting these entities. One of them is called a subclass, right? In this page, we provide an example of a subclass for you. As we can see at the top of this page, we can have a very basic product entity as shown here. For the product entity, it has three attributes: price, name, and category. And at the bottom of this page, we have two more products, which are special cases actually. The first one is called a software product. It has one attribute connected. It is the platforms of this software product. The other one we have is called the educational product. It has the age group as its attribute. Between this product with the bottom product, we connect them with the is A, this triangle. We have this is A, the top angle pointing to the product, the base case, as well as the bottom to the special case, the software product, as well as education product. And we connect them by the lines as shown here. So by drawing a diagram like this, we are indicating that this software product is a special product. It has some attributes, platforms. Besides this, it also contains the price, name, and as well as category inherited from the product base class. Similar for the educational product, it has a special attribute, age group. It also has a base attribute, price, name, and category inherited from the product, the base product we show here. So this is an example of a subclass. According to the previous example, you can see that the subclass generally denotes some special cases of a general entity. Like the education product or the software product, there are some special cases of the general product. Compared with the basic or general product, these special cases will have fewer entities in the real world. So for example, there will be much fewer software product compared with the general product, right? Because they are the special cases, the number of these entities will be much fewer. However, this subclass allows these special cases to have some special or unique properties or attributes. Like for the education product, we have the age group as one more special attribute of the product, right? Similar for the software product, we have these platforms as a more special attribute attached to it. We may also have some other examples in the real world, like the beers. Many students may like to drink beers or not. We know the beers can be divided into multiple categories depending on different criteria. For example, we can divide the beers into lagers as well as ales. So I do such a note online to differentiate the lager and the ales because I don't drink very often. And I also need to make it clear here, I'm not promoting drinking or beers in this class. We just use it as an example. If you don't like to drink or you don't like beers, you don't need to try the beers as we go over the slides. Okay, so we know that not every beer is ale, some can be lagers, right? And we can also create a ER model to model this relationship among beer as well as ale and lagers with a similar structure we showed before. So we know that these ales and lager may have some special attributes or properties compared with the very general beers. So let's assume that in addition to all the basic properties covering both the attributes and the relationships of the beers, we can also create some special attributes like the color to the ales. We have a diagram to show in the next page. And some students may compare the subclass with this class inheritance we learn from the programming language, especially the object-oriented programming language like Python or C++. They are very similar. However, they also have some differences. The first difference we need to mention here, in the ER model, we assume the subclass will form a tree. In other words, we don't allow this multiple inheritance among the entities. Therefore, for each of the special case, they can be connected by at most one is a triangle in our ER diagram. However, for a superclass, it can be connected by multiple ones, just like the one we show here. This software will be connected by one single is-A. However, for the product as a superclass, it can be connected by multiple is-A triangles as shown here. It will form a tree. And when we draw the is-A triangle in a ER diagram, please make sure we have the top angle of the triangle pointing to the superclass. Like here, this product is a superclass, this is a subclass. We have the top angle pointing to the superclass, and the bottom pointing to the subclass, and we connect them by the lines. This is something basic you need to know about subclass, and we can show example about these L's and B's in the ER diagram with subclass in the next page. In this page, we show the ER diagram we can draw to denote the subclass relationship between B's and the L's. So you can see in the top of this page, we have the B entity, either the base class or the superclass as shown here, with two attributes. The first one is the name, the second one is the manufacturer. At the bottom, we have the L's as a special class, and we also represent it as the entity with the corner as the attribute. Between them, we draw the is-A triangle with the top angle pointing to the B's, the superclass, and bottom pointing to the L's, the subclass. We connect them by the lines. Then here I have a question. So for the B's, we know it has two attributes, name and manufacturer. The question will be, for the L's, how many attributes do we have really? And you can think about it. We also need to clarify some differences between the subclass we learn from the ER model versus the knowledge we learn from the object-oriented programming course like C++ or Python or Java. So besides the difference we mentioned before, in the ER model, we don't allow this multiple inheritance among the classes. In other words, its inheritance relationships among entities will be a tree structure diagram. However, in object-oriented programming, we allow multiple inheritance. It is okay. Besides the difference, we also need to clarify the difference in the data storage. So we know in the object-oriented programming, objects will be in one single class only. No matter which class it belongs to, it can be a subclass or superclass. However, object will be in one class only. And subclass will inherit all the properties or attributes from superclass, and the data are stored in one memory block. However, in the ER model, these ER entities may have components in all the subclasses to which they belong to. What does this mean? Let's assume based on the ER diagram we show here, and we want to insert some data tuples about Peter's L. We need to insert this data into our database system. For the Peter's L, we have the name, the manufacturer, as well as the corner. So the data will be divided into two parts. The name and the manufacturer will be stored in the B's, and the corner and the remaining information will be stored in the L's instead. In other words, the data will be divided into two tables, depending on which part it belongs to, and it will store it into two tables as well. We can use one example to clarify this difference. Okay, so to further illustrate the difference between the ER model as well as the object-oriented programming in storing the subclasses, and we also want to provide some examples in this page. Let's focus on the object-oriented programming first. And let's assume we want to create some classes like beer as well as ale in some programming language. Since we don't specify the language we use here, we can define the class in a very general way. And let's assume we define class like this. We define class beer, and we list some attributes of this beer. So for the beer, we have two attributes. The first one we assume it to be a string name, and the second one is also a string manufacturer. Right. So this is the first class we can create. Let me also add some borders for it, so we can differentiate different classes we can create. The first class we have, and we create another class, the L. We define it in a very similar way. However, L is a subclass. It will be inherited from beers, so we can indicate beer as the base class out here. Inside this L, we have one single attribute. right? We'll have string color, like this. And then let's say we want to create two objects. Let me use object here. And the first object we want to create is like your beer equals to beer. And we can give two attributes. Name equals to your beer. It's an example, so this string doesn't have any concrete physical meanings. We just randomly write some names here. And manufacturer equals to like your home, like this. Let me use a small font. So this is the first object we can create for the beer, this class. And let's say we'll create another object, like my L. It's L. And the name will be my L. The manufacturer will be my home. And color will be like a light yellow. And will be like this. Okay, I'll use a small font. Let's maybe use 30. And we create two objects.